45. Welcome. Is it Chirag?
Chirag.
Chirag.
So if you see, we have bunch of open source project we are contributing to. A quick overview of what is the agenda. I will start with the introduction of Yocto project and Docker. Then I would go through the drawbacks of running Yocto builds on host. Then we will move on to see how Docker addresses these challenges. Then we'll go more detail about how Docker images can be used for Yocto builds. So starting from steps to build a Docker image from the Docker file, how container registry can help, and how to start a Docker container. Then I will do a quick live demo of building a Beagle Play image via Yocto using a Docker image that TI provides on its GitHub container registry. After seeing how Docker helps, we will go through few cases where Yocto builds might still fail inside a Docker container. And yeah, we will conclude. So disclaimers, this is a technology presentation and not a roadmap or commitment from TI. So the opinions here are presented by me and may not reflect to that of TI. A quick introduction about Yocto project. So as we know that it's a build system that helps us in creating packages from the source code. It's based on Bitbake and open embedded meta layer. It allows us to create a custom embedded Linux distribution regardless of the hardware architecture. Now, what is Docker? Docker is another open source containerization platform which allows us to package application and their dependencies into a lightweight and portable containers. So what you eventually do is you have a Docker image, put all the dependencies you want with respect to your Yocto build, and build a Docker image and store it onto a container registry. So we will see how we write this Docker file, convert that into a Docker image, and basically how we create containers where we actually run our Yocto builds. So what are the drawbacks of running Yocto builds on host? So traditionally we have been running Yocto builds directly on our host where we just go to the Yocto documentation, download the bunch of dependencies which are related to the packages, which are related to our distribution, and then start the Yocto build. However, this approach has some drawbacks. Firstly, the dependency hell. So managing dependencies and ensuring that the consistency is across all different development platforms can be a challenging. So it might happen that you are working on a Ubuntu 2204 distribution with your set of dependencies and your colleague is working on a different distribution like Fedora with other set of dependencies. So second is the reproducibility issues. So documenting build step doesn't guarantee consistent results across different machines. So we have the Yocto Foundation who is documenting for many distribution out there, but still that doesn't guarantee that we might end up having a 100% error-free Yocto build. And lastly, host system variability. So as I mentioned earlier, it might happen that each individual is working on a different Linux distribution, so, which has a different set of libraries, and it might affect the build process. And all this is resulting into this bad red error that we generally hate during a Yocto builds. So yeah, how we can use Docker to address these challenges. So Docker container provides an isolated environment for Yocto builds. So what it does, it provides consistency. So what we can do is just build the Docker image, put it onto a container registry, and ensure that everyone pulls the container image and uses the same. So it ensures that even if you and your colleague are on different distribution, you are still building the Yocto build with the same Docker image and which has the same environment. Second is portability. So developers can share their Docker image either via Docker registry or Docker also provides an option to convert your Docker image into a tarball, which you can share it over an email as well. So, and lastly, avoiding host system interface. So Docker kind of shields the build process from the host system changes. So yeah, that's how Docker helps in uh, addressing the challenges we see while running Yocto builds on directly on host. So moving on to the steps to build a Docker image for Yocto builds. So prerequisite would be to install and set up Docker on your host machine. Then step one is to write a Docker file. So let me go through and explain what a Docker file looks like. So Docker file is basically a text document where you have a bunch of commands and you say that these are the set of packages which I need during in my Docker image. So starting from the from statement. So this statement ensures that the Docker image which I am planning to build should be of the Ubuntu 22.04 distribution. So the final Docker image, the base distribution of that would be Ubuntu 22. So this is fixed. Now what we need is the set of dependencies. So if you go through the Yocto documentation for Ubuntu 22.04, we have this set of dependencies which are needed for Yocto builds to get started with Yocto build. So what we do is we use run command and we install the set of dependencies in the Docker image. Oops, yep. And the other run setup is to just set the locale permissions and to reconfigure bash as the default set, because we know that in Ubuntu it's dash which is preferred, but for Yocto builds we need to switch to bash. So yeah, we have this depcon set selections which we use and reconfigure the dash to not reconfigure basically the default shell to not be dash. Adding a bunch of users. So here I am basically creating a new user because I can't run Yocto build as a root user. So I'm creating a user which I'm naming it as TISDK, and then I'm adding it to sudo words and making it passwordless just because I don't want to have a password. And yeah, these are some bunch of locale settings we need, and I'm setting the user to TSDK as well. So this is how my Docker file will look like. So to convert this Docker file into a Docker image, all you need to do is run a Docker build command with inside the directory where you have this Docker file. Ensure that you give a good name to the Docker image so that once your images get built, you can identify it quickly. So we now have the Docker image on the host, but still, those were like two. There was still two steps that we were doing: writing a Docker file and then converting to an image. If you want to avoid the steps which are done in previous slide, all you do is build the Docker image once, push it to a container registry so that you don't rebuild the operations, redo the operations which were done previously. So yeah, we have a Docker image hosted on GitHub container registry, which can be used for Yocto build. So all you need to do is just Docker pull this image, create a container, and get started. So now I will show how to create a container. So we now have the Docker image ready on our host, either by building it ourselves or pulling it from a container registry. So the final step would be to start a container and get started with the Yocto builds. So what I will do is to start a container, what we do is we run a Docker run command, and with that, one important thing is for Yocto builds, as we know, we need few GBs of space, a hard disk space. So for that, what you should do is firstly and create a variable and basically assign a path where you want your Yocto build to get started. So I will just use that, set it to a work directory, and I will just mount the path which is on my host to home/tsdk, which is in my container. And just Docker run command with the Docker image is what I need to do to start a container. And as soon as I run that, I am inside a container. So quick summary on the Docker process. So either we build a Docker image from the Docker file or pull it from a container registry. Then what we do is start a container, and now we can go ahead with your Yocto build. So the only two steps which we have added is this before the Yocto builds. Yeah, so now I will try to show you a live demo where I will be building core image minimal for Beagle Play using the Docker image from the container registry which I showed. So, so if you are, so for beginners who might not be aware of what is Beagle Play, what they can do is to see which layer from Open Embedded Core is supporting that. What you can do is just hop on to the layers.openembedded.org and switch to machines. And here you just search for Beagle Play. And if you search, you see the machine name and you see the BSP layer which supports it. So it's the Meta TI. So that I will be using for my demo purpose as well. So firstly, the first step is to get a Docker image. So firstly, I will see if I do have some Docker image. No. So what I will do is I will run the docker pull command and I will fetch the Docker image. So what this does is, what Docker will do is fetch the image from the container registry. So I had the layers already in my system. So what it did is just clubbed the individual layer, created the Docker image, and now if I do Docker images, I have the layers. So pulling of Docker image is done. Now the next step is to start a container, but before that, as I said, we should ensure that we have a dedicated work environment. So for that, what I will do is I will export the present working directory as my working directory, which I will be eventually using for my Yocto build. And then I will just get started with my container. So these are some options that Docker provide. The Docker run command eventually provides. First is the interactive option, which basically allows me to provide a standard input when my container is started. T is for TTY, so it provides me a sudo TTY where I can basically work on. And -v is to mount volumes. So as I mentioned, I will be using present working directory, so I mount it to home/TISDK. Bash RC I am mountain is not compulsory, but right now as I am working on a TI based VPN setup, so I need some bunch of proxy setups for my Yocto build, which is in my Bash RC. So I am ensuring that that is also present inside my container. So that's it. And -w is to just specify the starting working directory. So as soon as I hit enter, I am inside the container, and if I do present working directory, it will be home/TISDK. So yeah, now I am inside container, and the next step is to start with Yocto build. So for that, as we saw that the Meta TI layer provides Beagle Play support. So what I will do is use the OE layer setup script. So this is basically setup script that TI still uses, which was based on Armstrong distribution. So it's highly inspired from that. So what this tool does is eventually it has a script, OE layer setup script, which will help us in layer configuration. So what I will do is just use a configuration file and run that script, and I will ensure that we clone all the layers. So By the way, till the Yocto layers are cloned, I would like to show the container registry page which we have. So we have documented all the process which I have been running through right now. So feel free to check it out. So my next step is to, which is the last step, is to bit bake a core image minimal from OE core using the Beagle Play machine configuration. So okay, so meanwhile the cloning happens, let me okay, it's probably done. So
Will you say how you copy the files back to the host?
yeah, we can do that. Yeah. So 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 we are,
Is this publicly relevant information that you might want to share with our remote listeners? Slava says yes.
so
It's just Michael was asking whether Shark is going to share how he copies files back to the host directory. So my suggestion was you could just bind mount the build directories right away, so they end up in a host, not in a container.
yeah, so as you mentioned, so I'm mounting my host system inside the container. So for storage, I'm still using my host system. So the files are eventually present on my host. So yeah, my cloning is eventually done, and I will move on to my build directory. Just few environment settings which we do, and I will bit bake a Beagle Play image. And so yeah, eventually my build is started, and yeah, this is how you run your Yocto build inside the Docker container. So the entire build is running inside a container, and yeah, so meanwhile the build is in progress. I will jump onto my slide to show what are the things which Docker doesn't guarantee. So yeah, is there any possibility that the Yocto builds will still fail inside Docker? So yeah, the answer is obviously yes. But most likely I have jotted down few reasons, and it can be one of the following. So either your host kernel is too old. So even though Docker provides a virtual environment, it uses the same kernel as that of your host system. So it might happen that your kernel is too older and Yocto is not supporting that. So ensure that you are still using a latest kernel image. Secondly, it might even happen that host has some packages which may conflict bitbake. So I would like to show a thread which was happening in bitbake. So it was related to AppArmor, which is a Linux security uh, package, and it was made mandatory in Ubuntu 24.04. So what it was doing is basically it was restricting the non-root users to basically access the storage, and it was creating some permission issues. So even if you have a Ubuntu 24.04, but and on top of that, if you have a Docker container which is still Ubuntu 22, still you might face this error. So it might happen that there are some packages in your system so which are conflicting the build. Third reason is definitely not having enough disk space and RAM size. And lastly, there might be some issues in your own custom implemented meta layers, and other issues can still exist like network issue, repository servers going down, etc. So a major takeaway from this session would be prefer running your Yocto builds in a containerized environment. These are a few references which I have attached, and yeah, I still have my Yocto build running.
Question was, you mentioned some incompatibilities with Ubuntu 24. Is it on the host or in the container?
Yeah, it is on the host. So even if you have a Ubuntu 24.04 host, and by default, AppArmor, which is a security package, which it was enabled by default. So even if you, let's say, have your Docker image on 22.04, you will still face an error. So that was my observations. So because this happens because Docker is still a process on top of your host system. So eventually Armor would be able to detect that some non-root user is trying to access something. So yeah, eventually it throws that error.
I just said I also use Docker a lot, but usually I also export my display and SD bus inside together with my network card and 2N, because then I can able to run task, EXP, and QEMU inside the Docker after I built it.
Okay, so you are unable to.
He is able to.
Okay. 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 Apparently the.
I tell you, 15 incomplete incarnations. Can you all just get into one room?
I was
Yeah, if
wondering.
you want, we can collaborate and come up with a single solution.
Thank you very much for the presentation. It was very interesting, and I'm pretty sure everyone in the room, one way or another, uses containers for reproducible builds. I personally tend to use KAS, and Joseph mentioned about this ongoing effort to have something within the Yocto project. So why do you start from scratch with creating your own Docker image and Docker file instead of using KAS or any of the other solutions?
Yeah, good
What is the
question.
benefit?
So if I heard right, the question was why did we start with a new container image from scratch rather than using corpse or maybe KAS container or stuff like that, right? So yeah, the use case which TI had was not to just support Yocto builds with a Docker container. So generally what we do is, so if you might be familiar, we have the task which we create to generate the SDK as well from Yocto. So generally what TI does is when we have a final tag on a kernel and U-boot, what we do is generate a SDK out of it. And the requirement was that SDK also should be able to be run inside the Docker container. And now that SDK has some bunch of tools and utilities which has additional dependencies other than Yocto build. So yeah, so that was the reason to start from scratch and create a Docker image which will solve both the purposes. That is the Yocto build as well as the tools and utilities which we have. So our U-boot also for K3 device supports uses the binman tool. So there are bunch of dependencies which are related to binman which are not needed while Yocto build, but will be needed if you want to use the SDK and basically compile U-boot from sources. So those were the additional, basically the set of dependencies that we wanted. So the goal was to have a single Docker image which would support both the SDK as well as the Yocto builds. So that's why we started from scratch.
Question was, you mentioned some incompatibilities with